the search for extraterrestrial life has always captivated humanity. For decades, we've looked to the stars, hoping to find signs of intelligent life beyond our world. Among the most exciting targets is the TRAPPIST-1 system, located about 40 light-years away. This system hosts 7 rocky planets, and some of them lie within the habitable zone, where conditions could allow liquid water to exist, potentially a key ingredient for life as we know it. What makes TRAPPIST-1 particularly fascinating is the proximity of its planets to one another, forming a tightly packed system that allows for unique opportunities in the hunt for extraterrestrial intelligence. SETI, the search for extraterrestrial intelligence, has long been on the forefront of this effort. Their mission? To scan the cosmos for signs that other civilizations are out there, trying to communicate, intentionally or not. TRAPPIST-1 has become a prime target for SETI researchers due to its proximity and the number of planets that could theoretically host life. But traditional methods of scanning for alien signals have come up short, so now, SETI is testing new, innovative approaches to increase the odds of finding something. We live in an age where technology is advancing rapidly, and with it, the tools to search the stars. In this series, we'll explore how SETI is using groundbreaking techniques to detect even the faintest whispers from the universe. Could TRAPPIST-1 be the key to unlocking the mystery of extraterrestrial life? Stick with us as we dive deeper into the science behind these new strategies and what they mean for our search for life beyond Earth. If you're fascinated by the search for alien life and the mysteries of our universe, don't forget to subscribe and hit the like button. And a special thank you to our channel donors, your support makes this exploration possible. SETI has been searching for signals from extraterrestrial civilizations for decades, but despite the vastness of the universe, the search has yielded no definitive results. One reason for this is that the traditional approach focuses on detecting powerful signals intentionally directed at Earth. These signals, however, may not exist or might be too weak for our current technology to detect. That's where a shift in strategy comes into play. Instead of waiting for a deliberate broadcast from an advanced civilization, SETI is now exploring the possibility of detecting leakage, incidental signals that are not meant for us but may escape from other planetary systems. One of the most promising innovations in this new approach is the use of planet occultations, PPOs. Occultations occur when one celestial object passes in front of another from our perspective. In the TRAPPIST-1 system, the planets are so closely packed that they frequently pass in front of each other as they orbit their star. During these moments, SETI scientists believe it's possible to capture transmissions between the planets, similar to the way Earth communicates with its spacecraft using NASA's Deep Space Network. Imagine the scenario: 2 planets in the TRAPPIST-1 system could be communicating with each other, exchanging data or signals. These transmissions might be similar to those we send to our own interplanetary probes, like the ones orbiting Mars. As the planets align, the signal between them could, in theory, be intercepted by our instruments here on Earth. This method gives us a chance to eavesdrop on alien communications, even if those signals weren't intended to reach us. The beauty of the TRAPPIST-1 system is its nearly edge-on alignment with Earth. This unique positioning allows for more PPO events to occur, which increases the likelihood of detecting something significant. By harnessing the natural configuration of these planets, SETI can perform a more targeted and efficient search, rather than scanning randomly across the sky. This isn't just theoretical. In their recent observations, SETI spent 28 hours focused on the TRAPPIST-1 system, listening during several PPO events. The challenge, however, is that any signals picked up could easily be drowned out by terrestrial interference. But thanks to new technology, such as the in-beam analysis pipeline developed for this project, scientists were able to sift through the noise and filter out signals that weren't coming from space. This new strategy represents a major leap forward in the search for extraterrestrial intelligence. It's no longer just about waiting for aliens to send us a message, it's about becoming more adept at listening in on the communications they might be having among themselves. As this method continues to evolve, the hope is that we'll get closer to answering one of the most profound questions humanity has ever asked: are we alone? In the most recent observations of the TRAPPIST-1 system, SETI researchers made use of cutting-edge techniques to filter through the vast number of signals that were detected. Over the course of 28 hours of observation, the Allen Telescope Array picked up an astonishing 25 million radio signals. However, almost all of these signals were caused by radio frequency interference, RFI, originating from Earth. Everything from cell phones to airport radar creates background noise that can overwhelm the signals SETI is looking for. This has always been one of the biggest hurdles in the search for extraterrestrial intelligence. Enter the in-beam analysis pipeline. This ingenious piece of software, developed by Nicholas Tucci and his team, was specifically designed to tackle the problem of RFI. The code works by analyzing the direction from which each signal originates. If a signal is coming from Earth or is being reflected by the Earth's atmosphere, it's classified as interference and eliminated. Only signals that seem to come directly from space, specifically from the direction of TRAPPIST-1, are flagged for further investigation. Thanks to this new tool, the 25 million signals that were originally detected were reduced to just over 2,000, a much more manageable number. But even among these, the vast majority were still found to be terrestrial in origin. This painstaking process of elimination might seem discouraging at first glance, but it's actually a huge step forward. By narrowing down the data, SETI researchers can focus their attention on only the most promising signals, increasing the chances of making a breakthrough. One of the key goals of this project was not just to find alien signals, but to demonstrate that the PPO method is feasible. And in that regard, the mission was a success. The Allen Telescope Array observed 7 distinct PPO events during the 28 hours it spent monitoring the TRAPPIST-1 system. Each of these events presented a unique opportunity to listen in on potential transmissions between planets, and the fact that no signals were detected doesn't mean we should give up hope. The lack of detected signals might be explained by the limitations of current technology. While the Allen Telescope Array is a powerful instrument, it's only sensitive enough to detect transmissions of a certain strength, specifically, those comparable to the signals sent by Earth's now-defunct Arecibo radio telescope. However, transmissions between planets in the TRAPPIST-1 system, if they exist, might be much weaker, similar to those sent by NASA's Deep Space Network, which communicates with spacecraft throughout our solar system. The DSN signals are relatively low-powered, designed to be just strong enough to reach their intended targets. So, while the Allen Telescope Array didn't detect any signs of alien communications, the experiment laid the groundwork for future searches. With the Square Kilometre Array, SKA, coming online in the next few years, we'll have access to a far more sensitive instrument capable of detecting weaker signals. The SKA, a massive network of radio telescopes spread across South Africa and Australia, will have the sensitivity to pick up DSN-level transmissions from the TRAPPIST-1 system during PPO events. This phase of the search has shown that the PPO method works. It's a game-changing strategy that could yield results as we continue to refine our techniques and build more powerful tools. The TRAPPIST-1 system, with its tightly packed planets and edge-on alignment, remains one of the most promising places in our galaxy to find evidence of extraterrestrial intelligence. We may not have found it yet, but this is just the beginning. The current limitations of our technology, specifically the Allen Telescope Array, mean that we can only detect very powerful signals, like those broadcast by Earth's now-collapsed Arecibo telescope. However, if alien civilizations are using lower-power transmissions, similar to NASA's Deep Space Network, DSN, it's no surprise that we haven't detected anything yet. The DSN signals, which are used to communicate with spacecraft in our solar system, wouldn't be powerful enough for the Allen Telescope Array to pick up from the distant TRAPPIST-1 system. But that's where the future looks brighter. With the upcoming Square Kilometre Array, SKA, expected to begin operations towards the end of this decade, we will have a far more sensitive tool at our disposal. The SKA will be able to detect much fainter signals, including those that resemble interplanetary communications, like the ones used by the DSN. This means that during planet-planet occultations, PPOs, in the TRAPPIST-1 system, we'll have a much better chance of picking up alien communications, if they exist. For now, the success of the recent observations lies in the fact that the PPO method has proven to be a feasible and innovative strategy. It opens up new avenues for SETI, allowing scientists to continue refining their search techniques and prepare for the moment when technology catches up to the signals that might be out there. As we continue to search the skies, one thing becomes clear: the question of whether we are alone in the universe remains as compelling as ever. The TRAPPIST-1 system is just one of many potential cradles of life, and while we haven't yet picked up any signs of alien civilizations, the search is far from over. What we've learned through these innovative methods, like planet-planet occultations, PPOs, is that the key to success might lie in finding new ways to listen, ways that take advantage of the natural movements of planets and the subtle signals they might be exchanging. The vastness of space and the incredible distances involved mean that the signals we're searching for could be faint, fleeting, or unlike anything we've ever imagined. But every step forward in technology and strategy brings us closer to the possibility of making contact. And if other civilizations are out there, they might be watching us too, using similar techniques to observe and listen in on our transmissions. This process of discovery, though challenging, reminds us that the search for extraterrestrial life is not just about finding alien civilizations, it's about expanding our understanding of the universe and our place within it. With the upcoming square-kilometer array, and as our methods continue to evolve, we are entering a new era of exploration where the possibility of finding extraterrestrial intelligence feels more tangible than ever before. If you believe in the power of curiosity and the pursuit of knowledge, now is the time to support this channel. By contributing, you're helping to fund discussions about our place in the cosmos and the search for life beyond Earth. Subscribe, share, and consider donating via the link or QR code below to help us continue exploring the universe's biggest questions together. The truth might be out there, and with your help, we'll be ready to find it.